Hello and welcome to Microsoft Virtual Academy. I'm Thomas Dawkins and I'm here with
Eric Downing.
Today we're going to share with you a MTA course called Software Testing Fundamentals. MTA stands for Microsoft Technology Associates, which is a certification that we have that is kind of our entry-level certification in our certification tree. This certification is aligned with exam number 98-379, Software Testing Fundamentals. You can take this exam at any Certiport or Prometric site. Just go to the site, register for the exam, and find out where is the nearest location for you to take this exam. So I'd like to introduce myself. I'm Thomas Dawkins. I'm a senior product manager within our LEX group, Learning Experiences group at Microsoft. I've been in the industry for over 30 years. 15 years of that has been at Microsoft. I've had many different roles, working in services, working in a number of product groups, done everything from support all the way to communications and marketing, and now I'm a product manager managing a number of products for the LEX group. Before coming to Microsoft, I was an MCSE and also an MCT focused on SQL Server. Eric, tell us a little bit about yourself.
Hi, I'm Eric Downing. I'm a senior SDET here at Microsoft. We'll refer to SDET many times in this presentation. SDET stands for Software Development, Engineering, and Test. I've been here at Microsoft for 13 years. I've specialized in software development lifecycle, automation, SQL Server, performance and load testing. I've been a test lead over a diverse set of applications, including legal applications, human resources, learning, compensation, and benefits.
So before we begin, let's talk a little bit about the MVA community. This is a free online learning that's available to IT pros and developers to help them keep up with the evolving technology that Microsoft provides to the industry. We currently have over 1.5 million registered users that are part of this community that gets access to these resources. So I'd like for you to take the time today, register, sign in, provide a profile so that you can be a part of this big community. So let's set expectations in regards to this course. First, the audience that this is targeted for are individuals that are looking to transition into an IT position, or you could be somebody that's new into the industry, just graduated from college or university, and you want to demonstrate your capability in software testing. There's a number of prerequisites that we have. One is we'd like for you to be familiar with the concepts of software testing. We also would like for you to have at least some level of hands-on experience with the technology. It's not required, but it is important that you have at least some experience, especially before you take your exam. When we think about the exam prep itself, we have a number of prescribed resources that we'd like for you to be able to look at. Their videos, their labs, and these are going to be important for you to prep for the 98-379 exam. So the Software Testing Fundamentals course is 6 modules. First, we'll go into testing fundamentals, where we'll talk about some of the basics relative to software and hardware, fundamentals of programming, software testing, and then introduce application lifecycle management to you. After that, we'll move into testing methodologies, where we'll talk about testing techniques, different testing levels and testing types. We'll then move into creating software tests, which we talk about testability, feature testing, and also how we appropriately scope test cases. From there, we'll move into Module 4, where we talk about managing testing projects. So we'll talk about milestones, the agile process, and distributed teams. We'll then go into Section 5, where we really talk about working with bugs, so how to detect them, how do we log them, how do we manage them moving forward. And then finally, we'll talk about automating software testing, which is really key, very important. Huge cost savings for a number of companies as they automate their test projects. So we'll talk about those strategies, how to write automated tests, and then also how do we manage test scripts. So let's go ahead and get started. As I mentioned once before, this module number 1 will focus on software testing, software and hardware components, the fundamentals of programming, and introduce to you application lifecycle management. So in this section, we'll talk about and cover measuring software quality and testing benefits. We'll also go into operating systems, network data, hardware and software, and how that relates to software and software testing. With each module, there'll be a number of guiding questions that we have made available for you. So the first question is, what is the purpose of testing during the software development process? How can software quality be measured? And then finally, what's the role of the operating system in a computer system? Seems like a pretty easy question to answer, doesn't it, Eric?
That's right.
So first, let's talk about understanding software testing. Now, software testing is critical, and you do this on a day-to-day basis, Eric. It really measures the quality of an application or project. When you think about a bug or an error in the code, what does that do to the application itself?
Well, what that's doing is it's giving the end user a result that's unexpected or undesirable, whether that's in the code or that's in the logic.
Yeah, so these tests help to find and correct those defects that we see in the code, which I think is very important. We also look at these tests to look at logic and also some of the functionality that's associated with the application, like security or usability or those types of things.
That's right.
So software testing is important as we think about that, as you think about developing applications. Nicely enough, and it's really important, is it also helps to reduce the cost of developing a program or an application.
Right.
I remember when I was at TAM in services, it's really interesting to look at what the costs are associated with having to dig for a bug. It cost our business groups a lot of money to pay for support people to go and deal with these, with problem applications. That's why Microsoft spends a lot of time, and we have people like yourself, SDETs, that are really focused on testing our software. When you think about this, what do you see as some of the benefits relative to software testing, and how does that impact our customers?
Well, the big benefits are going to be the loyalty and the word of mouth and the market share. And then if you're reducing costs for your end user, that's a really big deal.
Let's talk about some other benefits associated with testing. We talked a little bit about how it reduces the cost, not only for Microsoft, but it also reduces the cost for the end user, especially when it relates to training and user support. What are some of the other things?
Right. And as we just said, user satisfaction is a big deal to Microsoft.
It is. It's huge. So Lord Kelvin, back in the late 1800s, basically said, you cannot manage what you cannot measure. And that being said, if you think about how we manage applications, if we can't define good ways to measure the efficiencies of our products, then it's hard for us to manage those. So there are many different types of ways to measure software tests. Can you talk a little bit about some of the options that are out there and available?
Yeah. Sure. Metrics are always a big part of my job and a big part of the conversation when it comes to testing. Performance metrics, reliability metrics. There's a lot of bug metrics out there, and they're all agreed upon within your team. You got to work with your test team, your development team, your program management on what kind of metrics you're going to follow and how you're going to report those out.
Okay. So now let's talk about understanding the computer systems. Now, I look at this as being rudimentary and very basic, so bear with me as we cover this topic, but I think it's important to level set. The hardware in a computer system refers to all the physical elements of that computer system, like the keyboard, the mouse, hard drives, the CPU itself. There is software that is key and very important to that operating system because this controls all the allocation and the usage and the space, hard disk space, that's core to being able to manage not only the operating system but also applications that are built on that platform. And when I say platform, I'm talking about the operating system. Microsoft has multiple platforms. We have our Windows 8.1 platform, which is really on our Surface. We have our server platform. We also have our Windows Phone platform. So all of those have a flavor of an OS that applications get built on. There's also device drivers, and what happens is people have to develop these device drivers so that they can work with the operating systems themselves. So those device drivers also have to be tested, right?
That's right. And another important component that we have to take a lot of consideration of is the network. So simple things like every application is going to use the network in many ways. So your application is going to talk to your SQL Server database. The SQL Server database is going to have to hit the network for other reasons. So those are always come into play when we're designing and developing our test scenarios.
Yeah, one of my favorite applications now on the Windows Phone is this radar, and it basically shows you kind of a current radar view from your location. And it's interesting because it has to access the network to be able to pull down that information. So, that network connectivity and the access of that data is core to that application. So we had a number of questions that we talked about at the very beginning of the module. What is the purpose of testing during the software development process? Eric?
So most basically, that's to identify and report out the bugs. Now, it does go farther than that the more advanced you get. So as far as you become more advanced, you're going to start reporting out the quality of your feature, and then as you move up in your leading projects, it's the overall quality of your solution.
Next question is, how can software quality be measured? We talked a little bit about that. Give us some more detail there.
That's right. So you're going to be coming up with the metrics that your team is going to follow and your team's going to be interested in. So you're going to design and develop those metrics at the very beginning. Those are going to go into your test plan. A great example of that is the severity of the bugs found in a particular area and the counts of the bugs found in that area. That's going to become really important as you get further into the test pass and further into the project to determine if your coverage is actually heavy enough in that area, or if you need to allocate more resources to it, write more test cases around it. If you're finding an area that's particularly buggy, you need to do your research on that.
And then finally, what's the role of the operating system in a computer system?
So the operating system is going to allocate your resources, and it's going to also handle the interaction between the user and the application that they're trying to use.
Great. Well, this completes the first part of Section 1. Now we're going to move into the second part. But before we do so, I want to tell you a little bit about a Microsoft Pressbook that's very, very important, especially for those people that are either looking at becoming a tester or those that are currently testers. How we test software at Microsoft. This is available on Microsoft.com/learning. If you go into the book section, you're able to order it there, but you can also order it elsewhere. Now, let me tell you a little bit about this book. Alan Page, Ken Johnson, and R.J. Rollison are the authors of this book. I know Alan and R.J. are basically testing architects here in Microsoft, so that's about as high as you can get in the food chain of testers, right?
Yep.
So highly recommend this book, and I think you'll see benefit in this. So let's move to the second part where we'll talk about the fundamentals of programming and also introduce to you the application lifecycle management. So in this section, we'll review data types. We'll talk about distinguishing programming languages such as compiled or interpreted. We'll also talk briefly about analyzing symbol algorithms. Then we'll introduce the application lifecycle management. We'll talk about agile, waterfall, product, and project lifecycles. So, again, guiding questions. What happens when an interpreted application is built and executed? What are some of the most commonly used data types? And then how is agile development different from the waterfall model? So let's first talk about compiled versus interpretive languages. Compiled languages such as C++ are converted into machine language that is run by the operating system. This is what we call native code. Interpretive languages like C#, Visual Basic, F#, these are compiled into kind of an intermediate language before it's executed at runtime, where then it's translated into native code. So Eric, tell me a little bit more about the interpreted applications and how they're managed.
Right. So the important thing to understand about the interpreted applications like C#, for example, is C# is compiled and then it's translated by the intermediate language.
So it manages many of the different low-level tasks, such as memory management, security, and some of the other types of basis of the operating system, correct?
That's right.
Yeah. Okay. Now let's talk about data types. Now, data types are key, very important to how you think about writing your application, because you're always looking at data sources, or you may have stored data that you put inside the application's memory. These data types specify how that data is being stored and what are the values in that data set. I know that data types sometimes become problematic, and you see a lot of bugs that are really focused on data types. Can you talk a little bit about that, Eric?
That's right. So data types are interesting, and they'll come into play in pretty much any application that you're using. So you've got to test and you've got to think about how that data type is going to flow through the application. So as it goes through your user interface, for example, if you're asked to enter, say, an age, how that age is going to interact with maybe the web code or the C# code, how that's going to be moved through the stored procedures and then into the database and be stored, and then when it's pulled out, how it's going to be pulled out. And if there's going to be any conversions or if there's going to be any mismatches in the way that the data is handled or moved or converted as it goes through these, if you're considering dates, how C# handles a date versus SQL Server, or how it handles any kind of many different data types.
It's kind of interesting when you talk about age. I'd want to put in an integer instead of a float, because
Sure.
if I put 1.5 into that age field, it's probably going to error out on me because it was looking for an integer, correct?
Sure.
So simple things like that are really key, very important. So as you think about testing software, usually data types are kind of one of those key kind of sticking points.
That's right.
So now let's talk about different software development methodologies. There are many different models that we know of today for managing development projects. Each of them have advantages and disadvantages. I think that you do this every day, and I think that you're probably a known expert in regards to, as you think about both sequential and iterative development. Can you give us some insight and talk a little bit about both of those?
Sure. So we'll talk about, we'll start off with a waterfall methodology, it's going to be a sequential methodology, which meaning there are phases, and between the phases there's something referred to as phase gates. So if you've got the envisioning phase, which is the very beginning, your business is 100% involved, your program management's 100% involved. If you're the test lead on the project, you're involved. Before you can leave that envisioning phase, there is exit criteria you need to meet, and then there's actually a phase gate. Before you can enter the requirements phase, all of the tasks in the envisioning phase need to be complete, and actually that phase needs to be signed off, and you've got a meeting there where everyone agrees that you're leaving the one phase and you're entering the next phase. That's different.
Sounds like a lot of documentation on that one.
It's a lot of documentation, it's a lot of planning up front, and it's a lot of coordination. On the other side, there's a agile methodology, which particularly we use Scrum quite a bit, which is 2-week sprints, or 2 to 3 week sprints generally. They can be longer, they can actually be shorter, and the whole life cycle takes place within that 2 weeks. So that's obviously very different methodologies and very different uses for each of those methodologies.
Now you mentioned Agile, and then also you talked about Scrum. Now
That's
Scrum's an implementation of an Agile methodology.
That's
correct?
right.
Yeah, and Agile is really one of those iterative development methodologies that we have. As you think about teams, teams play a big role in really determining, how the software is going to be tested, and those teams interact differently depending upon the methodology that they use. Correct?
That's right. So in the waterfall methodology, the team is going to have specific tasks that they're going to complete, and they're going to meet with each other or meet with the different groups completely differently. For example, during a waterfall methodology, during the requirements phase, there's going to be a lot of meetings that test will be involved in some of them, and business will be involved in some of them, and the program management will be involved in all of them. Whereas in the stabilization phase, there are a lot of meetings, tests are involved in all of them, the business is involved in none of them, or very few of them, but you've got someone that's, maybe representing the business that's coming to help prioritize.
So testers
fixes and things.
Testers must like a lot of meetings.
Yeah, that's right. But the contrast to that is an iterative model like the Agile methodologies. You're going to have the whole team involved daily in a daily stand-up meeting. Everyone's going to be there, and there's a really strong feedback loop.
Good. So the customer's usually involved in those.
Customers
systems.
involved.
Oh, that's great. Okay. So we talked about the waterfall model,
That's
and this is an example of a sequential development. And some of the characteristics that as we mentioned once before, a lot of planning that's required up front. Teams heavily involved in a number of meetings throughout the process. There's gating factors for the phases. The team itself integrates on the different modules and tests the overall environment. When you think about that, again, the waterfall approach, a lot of planning. Coding doesn't begin until the design details are resolved, and that those gating factors or the exit criteria has been completely completed.
That's right. There's a lot of organization up front. There's a lot of time spent up front, and these are your big enterprise projects, your version 1 projects, where the upfront planning and the architecture is being developed. So this isn't something where you could iterate 2 weeks and really make the progress you need to make.
Don't you have to create big test plans as part of the waterfall?
That's right.
Model?
So the waterfall methodology is going to have one test plan that covers the project end to end. Where in an iterative project, you're going to have, like an Agile project, you're going to have a test plan every time you do an iteration. So every 2 to 3 weeks, you're going to be writing another test plan. And that's going to be a small test plan. It's going to cover the 2 or 3 user stories that are included in this project, and it's going to be pretty basic. It's going to be just enough to get you through that, and you're going to move on.
Cool. So here's a very simple example of a waterfall model. You want to kind of take us through this?
Sure. So you see the first step here is a requirements phase. So this is where the business has developed their user stories, and they're letting the program management and the development and test team know exactly what it is, what the problems are that they're trying to solve. So the business approaches the engineering team with a problem. They're not prescriptive about how to solve it. It's just, here's a problem that we need to solve. So once that is completely vetted out and the engineering team understands, then we all move into the design phase together.
That's based upon exit criteria being satisfied in that phase, right?
That's right.
Okay.
So we go into the design phase where the design is really vetted out and it's communicated to everyone, and really this is a very important phase in a waterfall project, because this is where a lot of the decisions are made on just how this is going to be done, the technical work. Then you go into the implementation phase where the code's actually written. So the developers are writing their code, the testers are writing their test cases and writing their automation. Once you reach that as a criteria, you go into the verification mode, which is also known as the stabilization phase.
Okay.
And this is where the bulk of the testing happens. And you've got your exit criteria here out of this phase. And we'll talk about this a little bit later when we're talking about the exit criteria for tests. But there'll be an example of that's going to be a certain percentage of your test cases will be run. This is all going to be laid out in your test plan. A certain percent or certain criteria will be met that you've agreed upon about what kind of bugs you're going to allow to out of this phase and into production. You know, if you've got severity 4 bugs that you're not concerned with, you probably agreed that it's okay to let some of these through. Once you reach that exit criteria, you get deployed into production, and you enter the maintenance phase where you are in production, and then bugs are logged against production, and you can put those in your product backlog for your next release.
This is where you really work with the support team and ensuring that they're helping you identify what those bugs are. Though they don't write the bug spec, they let you know what the challenges are they're having with the support. You guys go look at that and apply those into kind of what your laundry list of bugs are that you want to try to accomplish with the next rev of the product.
That's right.
Great. So now let's talk about Agile. So this is primarily the methodology that you and your team use today, isn't it, Eric?
That's right. For the smaller projects or the versioning of projects we do, we use a lot of the Agile methodology. Like I said, for the enterprise V1 projects, Agile doesn't fit as well,
Okay.
so we're going to use a waterfall model for something like that.
So Agile is really this development methodology is incremental. It's rapid cycles, small incremental releases. Nice part about these small incremental releases is it gives the opportunity for you to check with your user, your customer, to better understand whether or not you're meeting the mark or not. And then you may also go in and as you do your tests, those tests become a part of that development process.
That's right.
So when you think about the projects themselves, what do you think is the most key thing that's a value for the test team when you think about the Agile development process?
Right. So that's deliver early, deliver often, get quick user feedback, and get that back into your infrastructure and get ready for the next release.
Okay. Yeah, the next sprint, right?
That's right.
Okay. So let's go into the Agile model. I think it's important that as we think of Agile as a development process, that we truly understand what those sprints are or phases. So can you kind of walk us through what this looks like?
Yeah, so you'll start at the top here, and you'll see the planning phase, and you see that gray arrow that starts the start of the project. So you start with your planning phase, and the first thing you do is you decide on how long your sprints are going to be. Like I said, you're looking at, they're very quick, 2 or 3 weeks. And you're going to have your planning phase there. You've got your product backlog, which is going to have a whole bunch of items in it, and they're prioritized, they're stack ranked. And you're going to look at that product backlog and agree as a team. And you've got your estimations, your time estimations in there, and you're going to say, hey, in 2 weeks, I can do the top whatever number of these items. And it might be 1 item, it might be 2, it might be 3. And maybe you're going to take the first one and the second one. The third one may have a high estimate on it, so maybe you've got a couple more days of capacity. You might take number 1, number 2, and number 5. And you're going to say, You're going to talk to the business and say, these are the items we're going for next. And you're going to go right into your implementation phase there. You're going to be writing your test cases at right alongside the code that's being written. It's going to get quickly delivered to the test team. You're going to test that to get that deployed into production. You're going to have your feedback time, and that's going to be the time to do the retrospective, to look back at the that last process, see how things went, look back at the assumptions you made, and see kind of what maybe mistakes that there were in the assumptions, and you can use all that information to go into the planning phase next time. That evaluation and feedback time is also really good to get your customer feedback on how you implemented that user requirement, and there may be another requirement that stems from that, or that can go back into your backlog again and get prioritized, and you step right back into the planning phase again.
Cool. That's excellent. So we have a number of section questions that we want to try to answer. One, first, is what happens when an interpretive application is built and executed?
The important thing to remember here is it's compiled into an intermediate language, and then it's translated by the just-in-time compiler.
Okay, into that native code.
That's right.
Yep. What are some commonly used data types? We talked about a couple. We talked about integer and float. What are some of the other ones that you've...
So you've got a Boolean data type. That's your true-false.
Yep.
You've got your numeric data types. There's a lot of numeric data types. Mm-hmm. You've got your strings. I'd say those are the most common basic data types that.
So if we don't know what string is, what is string?
So string that's going to be your characters, okay. Your alphanumeric characters.
Okay. All right. And then finally, how is agile development different from a waterfall? And we talked a lot about the differences from a team perspective, from a phasing standpoint. Just kind of give us a high-level overview.
Right. So waterfall is going to have a lengthy design process, and it's going to have it's got the phase gates that are kind of set in stone. And then agile is going to be short, rapid cycles, and its benefit is the feedback loop.
Okay, great. So as I mentioned once before, we have a number of additional resources for you to look at, especially for those of you that are looking at taking the exam. A couple of things I want to just definitely point out is the lab. There's a walkthrough for analyzing managed code for defects. I also think that the testing overview and testing early and often, those two are also very important as you think about prepping for the 98 379 exam. Last thing I want to talk about before we end this module is, this is a good first step for somebody that wants to obtain a Microsoft Certified Solutions Developer certification for application lifecycle management. So I've provided a link here for people to get access to the information for that. But a lot of the things that we're talking about today at a very high level, you'll go into more detail as a part of this certification, taking either some of the online courses or possibly taking a class that focuses on helping you prepare for this exam. This concludes Module 1 of Software Testing Fundamentals. We want to thank you for being here today, and we look forward to you attending some of our other modules.